Now back to the another session. In this session, we'll be knowing more of the C programming, going in depth with the programming rules, what are the programming rules, and what the character set we are supposed to use as a part of the C programming language, what are tokens, what are variables, what is a data type, what are format specifiers and input output functions. And coming to the programming rules of the C, as we know, C is a programming language which comes with some constructs and the constants. So all the statements of the C programming language, all the statements of the C programming language need to end with a semicolon. As I already showed you what is happening if at all I am missing a semicolon. As all need to be started with a end with a semicolon, and except some keywords and the functions. And as C is a case sensitive, I told you how different the key is going to be a case sensitive, how it is going to differentiate between a small letter and a capital letter. Even as soon as we finish this, I'll be showing you how the case sensitiveness is going to be. And free form of language, why it is called as a free form of language means it is not restricting. C is not restricting us to go for making the writing the statements only from certain step or certain area. I'll show you why it is a free form of language when I go for writing the program after this session immediately. And I can have a group of statements on one line, or it can be split into multiple lines. And this will be also will be seeing practically. And braces must always match upon pairs, and this also we are supposed to see immediately after this session, how the braces need to be matched on, why it is a case sensitive, and what happens without semicolon, how we can go for grouping the statements in a C program, and what the character set the C program consists of. If at all you look at what all we can use in writing a C program, in writing a C program, what all we can may go for using, and that we call it as a character set of C. Character set of C. As we know, English has a character set, alphabets, grammar, rules, regulations. In the similar way, C program is also have a character set. C program is also have a character set, and that character set consists of four. One is alphabet. Character set is of four types. One is alphabets, alphabets from A to Z, small a to Z, capital A to Z, small a to Z, and next character set is digits 0 to 9. 0 to 9, and then we have the symbols which can be used, whatever the symbols are available on our computer system, all those symbols can be used in our C programming, but not wherever we want. They are going to be used in a specific way. Ash, as already we have come across, the ash as is used to include the header files. In the similar way, we have the fourth character set is a backspace, blank space, tab space. Right now we already used one slash n. Slash n also comes to the this fourth character set, this escape sequence. Okay, so this is what the character sets we can use as a part of C programming. And moving to what is a token, first we need to know what is a token. What's a token? When we see of a token, what is a token in C? Not only in C, a token is the smallest unit of a program. Token is a smallest unit of a program. So when we think of what are the units of our program are, when we write a program, what are the units of C program? C program has the keywords. C program will have a keyword. C program will have the strings. C programs will have operators, special characters, constraints, and identifiers. These are the smallest units of our C program. By making use of all these tokens, by making use of tokens, and tokens and character set, making use of character set, tokens, rules, what we call syntaxes, syntactical rules, we write programs. We write programs. Without them, no programs. That means what are programs? Our instructions. Whatever we write, the instructions, they are going to be the collection of tokens, character set, and syntaxes. Making use of all of them, we go for writing the program. So C tokens are of 6 tokens. They are keywords, operators, strings, special characters, constants, and identifiers. So moving ahead, what is a keyword? These are the tokens. Why? Because we are going to make use of keywords, tokens. So using all of them, we go for writing the programs. So what is a keyword in C? Keyword is a word which has a fixed meaning in the programming language. Fixed meaning. Its meaning is not going to be changed, and it cannot be used other than the functionality it is meant for to be used. What for it mean to be used, only for that it need to be used. Other than that, it is not supposed to be used. It is fixed. It has a fixed meaning, and it cannot be duplicated. So C has 32 keywords here. Auto, break, case, character, constant, double, else, enum, extend, float, int, long, register, return, short, struct, switch, type def, union, do, while, continue, size, default, undersigned, static, if, volatile, signed, for, void, go to. And these are all the keywords. These are all the keywords. They have fixed meaning in the C programming language. And when we go for making use of all these keywords, we'll be able to understand what for exactly they are meant for. Other than that, we are not supposed to use anywhere else. So what is a keyword? A keyword which has a fixed meaning in the library of the C, we call them as a keyword. And these keywords are also known as, we call them even as reserved words. You can understand reserved. That means they are reserved. They can't be used by us. They can't be used by us whatever the way we want. They need to be used only the way programming language is telling us to use. Where it need to be used, only there it can be used, but not wherever we want. That's what the keyword role of keyword or the reserved words are. Then coming to the identifier. Identifier is also a token. Identifier is also a token. What is identifier is? Identifier can be a name given to a data, given to an object. Whenever I go for giving a name to an object or a value, it is going to have a memory space in the memory of the computer and unique address in the memory of a computer. That's where when we are writing an algorithm, I said X, I said A, I said B, I said L, we used something like this. What are all these? These are all nothing but some letters used, there are some symbols used to represent some values in the program. So all these are called as the identifiers. They are the names. X is a name assigned. X is a character. X is a symbol. As when I say X equal to 5, what is this X equal to 5? X is a name. X is a symbol which is holding a value 5 in the memory of the program, in the memory of the system. So this X is an identifier, name of the value. Phi as a name in the sense phi is not going to have a name, phi as the name, and this name is going to have a location in the memory. In that location 5 is going to be stored. So identifiers allow us to name data, other objects in the program. So they have unique address, and they are going to be stored in an address. So different languages use different syntactical rules to form identifiers. So it's not same for all the languages where we go for making use of the identifier. As I shown you here, he is a person, a man, a person, a person, a person, and everyone has a name. What is this name? Name. This person is going to be identified with this name. This person is going to be identified this name. This person will be identified in this name. So what is an identifier? A name which can be assigned to an object, assigned to a value. They are the identifiers. So we use identifiers, we use tokens, we use character sets, we use the rules of the programming language to write the programs. And next, moving ahead to the rules used for identifiers. When we go for defining a name, what are the rules? See that alphabet, the first character of the name should start only with a character and with an underscore. Other than this, we are not supposed to use anything else. It is a rule in C programming language, and it should must contain only the alphabets, digits, and underscores, not anything else. No other special character can be the part of our name. That means the name we use in the program, and the first 63 characters of the identifiers are significant. Of course, this I am going to rule out because we are not going to give such a big name to our values which are going to be used as a part of our program. We use only 3 or 4 digits, or 3 or 4, maximum 5 to 6 digits. And as I told you, keywords and the reserved words cannot be used, cannot be duplicated to make use of them in our programming. So that these are the rules which we are supposed to keep in mind while writing a program. Then coming to what is a variable. I said now in my program I go for writing x equal to 5. What is this x? X equal to 5. What is this x? This x is a variable. What x is a variable? As variable is a meaningful name given to the data. Variable, it's a name given to the data, meaningful name given to this data, and have a location, a storage location in the computer, memory in the computer. So already I told you it is going to store in the memory in the computer. So it's a meaningful name. And this x, its value may change. That's the reason why I'm calling it as a variable. Variable means changeable. When I write in my first statement x equal to 10, in the second statement I write x equal to 20. Then if at all I ask to print my computer what is x value, it prints only 20, not 10. It prints 20. Why? Because in first line I have written 10, but in the next line for the same name I have written 20. So it is overlapped, or in the same memory location, the 20 will be replaced by the 10 will be replaced by 20. So I get the value only 20. So variable may change its value while the execution of the program. That's what we call it as a variable. So how do we name variables? So variables are the names which need to be declared before we go for making use of them in the program. When we go for writing a program, variables need to be declared before we use them. It's a symbolic name. It's some representation of the memory where I can go for storing the value. That's what the variable is. So before I use anything in the program, they need to be declared. And once after declaration, they need to be defined or initialized. We go for calling them as the initialization. Declaration and initialization. So when I think of a variable, immediately I need to even understand what is a data type. If variables type can be any of the data types, you need to understand what is a data type. When I say a variable can be can be a character, can be an integer, can be a real. It can hold a value of character, it can hold a value of integer, it can hold a value of real type, or it can hold a value of something else. What kind of value it can hold, what kind of value it can store, and that is defined by the data types of the programming language. Data types of the programming. So let's see what is a data type. So what is a data type? When I say data type, what is a data type? A data type defines a set of values or set of operations that can be applied on those values. So this is what the statement given by the text, but I'm not going to tell you, as I'll say in a simplest way. Data type defines what kind of value is going to store in the variable. What is variable? For example, I go for writing x equal to 5. X equal to 5. This is a variable. X is a variable and value is 5. And I am assigning this value to the variable with an assignment operator equal to symbol. Okay, as of now, we are not bothered. What is this operator? Is equal to symbol. So I need to mention when I am using x, what x can store in it. X can store what kind of value? Can x store 5? Can x store a? Can x store SRU? Or can x store 5.10? What x can store in it? What kind of data this x can store? This x can store 5, or this x can store a character, or this x can store a word, or this x can store a 5.10. This is an integer value, it is an integer value, it is a character value, it is a word, and it is a decimal point value. What my x can store, I need to tell in my program. When I go for making use of this x or a variable x, I need to tell in my program what this x can store. So that is what a data type is. What is a data type? Data type specifies what kind of value I can store in my variable, and that's what we call it as a data type. And when comes to the C data types, C data types are of three types. When you look at the C data types, they're of three types. One, primary data type, derived data type, and user defined data types. For now, we just not going into the depth of derived and data types. Derived data types and user defined data types. Will be knowing the primary data types of C language, and they are void, integral, floating point. Void, integral, and floating point. What is void? I'll tell you here. When I say void, void represents empty. Void represents empty. Empty. Void represents empty. This void is a keyword. It is a keyword. It is a reserved word in the character set of C language. And it is used with some functions where functions doesn't return anything, where functions doesn't have any parameters. That's what we use. That's where we use void. But now never ever go for using void to declare a data type of a variable, because if at all I write void x, void x, what void mean? Empty. That means my x is not going to store anything. My x can't store anything. When x can't store anything, what is the use of x? Waste. So never ever go for using a data type of void to declare a variable. That's what a void is. And then coming to the next two types of the data types, one is integral and the float. What is integral? When it comes to the integral data type of the C, in integral we have three types of the data types. One is Boolean, the other one is character, the other one is integer. What the Boolean type of data type says? This Boolean type of data type says as it stores true or false. True or false. 1 or 0. Yes. When I say Boolean, I write here bool x. Bool is a keyword or a result word to define my x as a Boolean data type. I write bool x equal to true. I write true. When I say print x, what the value I get, it is true. It is true in the sense I get one value output. So it stores either true or false, Boolean character, Boolean data type. That's what the Boolean data type is. Character data type. When I say character data type, I need to use a keyword called character. Remember here, character. CHAR is a keyword used to define a character type of the variable, and I say x. X equal to, I need to assign a character. I am assigning a character A within the single quotes. Now, x is a variable, x is an identifier, x is a symbol which can store a value called A. Which can store a value called A. Why it can store a value called A? Because I declared this variable which can store only the type of character data. That's what the character data is. And when it comes to the integer, when I say integer type of data, so I need to declare int x equal to 10. When I say int, my x can store only the values of type integers. If at all I write x equal to 10.10, even though I write 10.10, my x will store only 10, only integer value, not the decimal value, not the decimal value. That's what the data types define. So we have integer, character, float, Boolean. And when we comes to the next data type, we have the floating point. What is a floating point? The primary, very basic data types I'm saying here. What is a floating point? For example, if at all I want to make my variable a floating point variable, I use a keyword float. Float x equal to 10.10. Now my this x can go for storing a value with decimals. Here, when I go for declaring float x equal to 10.10, my x is now can go for storing a value with the decimal points. A value with the decimal points. Even when I don't go for giving a value as even I go for giving a value as only integer value. I write my data type as float. I write data type as float x equal to 10. No issues, it takes. Why? Because this 10 can be treated as 10.00. It takes. And when I go for giving an output, x equal to float x output, then it gives me 10.00. But for integer, it never accepts the decimal points. That's what the different data types we see in C language. One is the integer, one is the character, one is the float, one is Boolean. Other than this, we have one more as in the flow in the character data type, we have one more data type, that is a string data type. If at all I want to store a word, not as entire word need to be stored to a variable, then I go for taking as string character or the str to store the a value into a variable. So let's move ahead and see what all the data types are and what the ranges of this data type. This is only for your glance. When I say character, in the computer memory, it is going to store 1 byte. When I say unsigned character, it is also going to store 1 byte. And integer, short integer 1 byte, unshort integer 1 byte, and integer 2 bytes or 4 bytes, unsigned 2 bytes, and long integer 4 bytes, float 4 bytes, double 4 byte, and long double. And this is the memory space required by different data types in the computer memory to store them. And these are the ranges from which we can go for storing the values in them. If minus 128 to 127, if at all we go for taking a character, I can go for storing 255 characters like this, and 255 characters, and the value from 32768 to 32767. These are the different ranges. It is only for your reference, which you can have a look in the textbook or anywhere else. And next, move into an example program. What is the data type is given here. It specifies what kind of value it is going to store in the variable. To make is an example of a data type, and I give my my program starts with the main, and I have the body of the program. Body of the program, body of the program, and in the body of the program I have the variables. Now you can go for thinking this is a variable, this is a variable, it's a variable. A is a variable, B is a variable, C is a variable, and now my variable I have written it as int. This we have not seen in algorithm or the flowchart. Int, what does this mean? Int, that means my A can go for storing only integer values, not other values, only integer values. It cannot store character, it cannot store words, it cannot store letters, it cannot store decimal values. It can store only a integer value. That's why I declared A equal to 5, B equal to 6. This is what I call it as a declaration. Declaration of variables, and this is what we call, sorry, this is called defining or initialization. Initializing and declaring. I declared the variables, I initialized the variables, or I defined the variables. I given a definition. What is the definition? I said A equal to 5, B equal to 6. Then I have an expression, a computational expression, where C equal to A plus B. Now my program takes 5, 6, computes A plus B, and stores in the variable C, integer kind of variable C, and prints an output of C. And when you look at this output, immediately you need to get it out. Whatever I write in between inverted commas will be given as an output. But I wrote something here different, percentage D. What this percentage D is? Because my C is a variable which is storing a value of integer data type. And that integer data type need to be given out now. To give that integer data type, I need to specify a control string. This is called as a control string or format specifier. We call them it as a format specifier. What kind of data is stored in that variable need to be mentioned within the printf function or the output function, so that it only give the output. Otherwise it will not give you the output. You will get some garbage output, useless output will be given. So what kind of value is stored in this variable need to be mentioned within the printf function, so that we call it as a format specifier or the control strings. So for integers we use format specifier percentage D, that is only for printing out the an integer. Okay, and moving ahead to the control strings or the format specifiers to know for ourselves. For characters we use control C, for strings we use control S, percentage C, percentage S, and we use for integer we see a percentage D, and for floating point or the decimal values we go for using a percentage F. Moving ahead, we go for seeing an example program to calculate the simple interest using the data types and the format specifier. This is my main program. Of course, I skipped here writing the header file. You don't skip writing the header file because you are using a printf statement. Definitely you need to add here hash include stdio.h. Never ever go for skipping this. Hash include stdio.h. You need to write. Then header file is added, then main, then the body of the main has been started. In the body, I have taken for finding out the simple interest how many values or how many symbols I required four symbols. One is for entering principal amount, one is for time period, one is for rate of interest, the other one is for calculating simple interest. And what kind of value I am going to store in all the four variables is integer kind of value. Then integer kind of value I have given p value. This is what the declaration is done and initialization or definition is done, and t equal to 2 and r equal to 3. Then I'm computing the simple interest si equal to ptr by 100 computed, and then I'm giving you the output, and the output is simple interest for 2000 with a time period of 2 and with a rate of interest 3, and percentage d is given within the printf within this inverted commas to give the value which is present in the si. What kind of value? An integer type of value. This is how I go for writing a program in C to find the simplest. The same program which can be written in a simplified manner as main, and here you can go for seeing in one statement have given the entire thing. Int p equal to 2000. Here I given separate. That's what I said. I can split. I can write in a single line. Somewhere in the properties of the C language, I can split the statement into number of lines, or I can combine the statement into a single line. Integer p equal to 2000, t equal to 2 comma, r equal to 3 comma, si. This is also right way. Then I just calculated the simple interest, and then I made to print out the simple interest of the, you can see here printf is used within the inverted commas. I wrote simple interest equal to percentage d then si, and this si is going to give the value stored in si with a integer type of value. And this program, both the programs give me the same result, but the way I write the program is different. So that's left to you. How do you write the programs? And coming to the input output statements, and when I say C has the input output, doesn't have any input output statements predefined, but it has the predefined functions, library functions, which can be used for giving an input to the program and getting an output from the program. And those input and output functions are scanf is an input function and printf is an output function, which can be used in C program in writing the programs. And all those library functions or the input output functions will be stored in standard IO library function. And these standard IO library functions, they stay or they reside or they will be in standard stdio.h header file. That is the reason whenever I'm using a printf function or a scanf function, I need to go for using standard stdio.h header file, this header file. Okay. And input output functions, when we come to the input output functions, or in C, input output functions are of two types basically. And those two types of unformatted functions and the formatted functions. When we think of an unformatted function, it doesn't bother what kind of data it is taking or what kind of data it is giving. When we come to the formatted, it is bothered of what kind of data it is taking, what kind of data it is giving. So that is formatted. Function that accepts strings as well, variable number of arguments to be displayed, read in specified format are called as formatted functions, formatted IO functions. That means they need to know specified format, what kind of data it is supposed to give, what kind of data it is supposed to take. Knowing that it takes the data or gives the data, and such kind of functions we call them as the scanf or printf functions, or in formatted IO functions, formatted input output function. If my function is not bothered what kind of data it is taking, what kind of data it is giving, then we call them as a unformatted IO functions. So printf, as we already been making use of the printf function is used to display information required by the user on the screen or values on the screen. or values assigned to the variables on the screen. So that's where printf is control string, or the control string or the data whichever we want to display, it is written within inverted commas and then followed by the variables. These are all the variables. Example, printf hello world, whatever is written within the inverted commas will be printed as it is, and you all know this slash n is used for new line. And when it comes to the next example, printf percentage %c, percentage %d, percentage %f, they're all the format specifier. In this a we have the character kind of data, in this b we have the integer kind of data, in the c we have the float kind of data. So I'm going to get the output a b c, one character, one integer, one float. And remember always that when you are writing the format specifiers in the printf, never ever go for using commas or spaces in between them. And one more thing also, you need to keep in mind that what the order, what the way we have here, in the same way we are supposed to have here. For example, a is holding a character type data, and here the character is first, here the even the variable need to be first, and here the integer is second, here the integer need to be second. If at all they are unordered, immediately my output statement is not going to work, it gives me an error. Similarly, to coming to the scanf function, I already told you, still now we have not used the scanf function. It is an input function. It is an input function. It reads the formatted data from the user. It takes the data from the user, formatted. That means we need to mention what kind of data we are giving to the program, need to be mentioned. And those data types can be numerical values or characters or strings, etc. Anything from the keyboard. But it should be mentioned within the inverted commas of the scanf function, within the inverted commas of the scanf function. And later we need to mention the variable names, I'll just go for explaining you this. Scanf is a function, input function used, and I'm mentioning it is going to take one character type of data, one integer type of data, one float kind of data, and it is closed. And here I just ampersand a. This is very, very important. You need to remember what does this ampersand a, we call this and symbol as the ampersand a. What does this ampersand stands? When I'm saying scanf, I'm telling my computer, my program, take a value which is of character kind of data and store in the address of a. As I told you, when I declare a, as when I say character a, character a, character a, this variable is going to have a unique address in the memory space of the computer. It will hold a unique address. Why? Because whatever the value I give it to the a, this need to be stored in some address of the memory. So that address, how do you mention? I am saying through input function. What is that input function? I am saying take whatever I am giving value to a and store it in the address, store it in the address, and that address is mentioned using ampersand. So scanf ampersand a means take the value of character type and store it in the address of a. When I say ampersand b, take the value of integer data, integer, and store it in the address of b. When I say ampersand say, I'm saying my program take float value and store in the address of c. That's what the ampersand means. Read the data from the user and store it in the address of C. That's what the ampersand says. So when you are reading or when you are using input function, definitely all the variables need to be specified with their addresses. For output, there is no need. For output, just a comma b comma c, it gives the output. But for storing the data in the memory or placing the data in the memory, then we need to use the address, that is ampersand a, ampersand b, ampersand c. That's different. So here we have the example program using of scanf and printf. Hash include stdio.h, header file is included, and main, here comes my main body, and in main function I have the integer data type. One is integer data type a comma b comma sum. A is a variable, b is a variable, sum is a variable of integer data type, and then I have a scanf statement. You can see scanf statement. Scanf percentage d, what kind of data I am asking to store? Integer type of data, then I need to use scanf. If it is character kind of data, I need to use percentage c. If it is float kind of data, I need to use percentage f. If it is a string kind of data, I need to use percentage s. So I used percentage d, and I'm asking whatever the value I give while executing the program should store in the address of A. That is the reason I need to write here ampersand A. Then next value I am going to give. Next value I am going to give for B, and I'm saying it is also an integer type of value and store in the address of B. Then I am calculating the sum A plus B, and then I am printing the output. You can see here I have only the type of the data it need to be give the output. Then I mention the variable name sum. I get the output sum of these two numbers. And the same program I write in this some different way. To more specific hash include stdio.h main and int a comma b comma sum. I entered, see, I used output statement printf, enter the value of a. Then I asked input statement scanf percentage d ampersand a to store the value in the address. Then I asked enter the value for b. Then I asked to take the data from the user and store it in the address of b. And then I computed or calculated the addition of two numbers a comma a plus b. Then my output I am giving it as you can look at here, sum of percentage d, that is a. What is a? What the value I give in a is going to be printed here, and then percentage d, what the value I give in b is going to be printed here. Then percentage d, the sum value will be printed here. For example, I enter a value here 10, and that 10 will be taken and stored in the address of a. And when I enter a value here 20, and that 20 will be taken and stored in the value of in the address of b. And after that my computation will be done like sum is equal to 10 plus 20, and the value is going to be 30, and this 30 will be assigned to the sum, and this 30, now my a, the memory block a, this is a, and this is a memory block contains 10, and we have one more memory block in computer, and that where contains 20, and which is represented with b. And I have one more memory block with named as sum, and that memory contains value 30. So this address, it has a address, and this address is represented with ampersand. So whenever I say ampersand, it takes and stores in the address of a, it takes and stores in the address of b, stores and it stores in the address of sum. So whenever I say in the printf statement, output statement a, directly it takes the value that is an integer value. I get the integer value 10 here, I get the integer value 20 here, I get the output, the sum of 10 and 20 equal to, what is the sum? Sum is 30. I call a b sum, so I get the sum of 10 and 20 is equal to 30. This is how the output I get from the compiler or the program. And the same program I made it a little more different. See, there I used, if at all you look, I used more number of statements here, one or two number of statements are more, and the same program I made it more simpler using stdio.h and main int. I asked the enter two numbers, and I asked the printf scanf percentage dd ampersand a and b. I used ampersand a and b. And I'm making the sum, and I'm asking to print the same statement, print whatever I'm going to enter two numbers. I enter 10 comma 20, and that 10 comma 20 will be stored for a, and b is 20, and some block in the memory will be containing 30, and I get the value 10, 20 and 30. And this is what the output I get when I execute this program. Okay, let's see. We have seen the variables, data types, tokens, and input-output functions. I'll be showing you the execution of one or two programs in using Dev C++. Then we can wind up definitely for today. And let's have one program making use of the input functions, output function, header file, and a variable. I'll start writing the program with the header file. As we know, we are supposed to write the header file in the starting when we go for using the input functions. Declaration of the variables with the specified data type, int. Say I'm taking an int a, Look at here, int a, I've taken a variable of integer data type so that my a stores only integer value. I'm going to take another data type, int b, float b, comma, I'm taking sum. You can go for taking any kind of data type, but make sure that you are using the appropriate one which is required to get the result of your problem. Then I go for saying printf, I want the output printf, enter the value of a. See, I'm making some decorations, no issues, enter value for a. And I say scanf, this is the input statement, scanf. And I need to write something in between inverted commas. That inverted commas is what kind of data my scanf need to take from me. What kind of data I'm taking, enter a. A is of integer data type. So I say percentage D and comma ampersand a. I need to store in the address of a. And I say ampersand a. It will take a value of a and stores in the address of a. And that value is going to be integer type. Now I'm saying another as printf, enter the value of b. Done. Now I'm reading. When it asks me to enter the value, it should take the input from me. So for that, I need to write scanf. And what kind of data it need to read? As it need to read float kind of data. I'm writing float means decimal point, a value which can take points, decimal points, comma, where I need to store in the variable b. So address of b, ampersand of b, end. Then after taking two values, I'm going to store the summation or addition of those two numbers, a comma b, a comma and c, a and b in sum. So stored. Now I'm saying printf. You can look at printf, the sum is as where my sum is present in percentage float, that is f. So what I do is comma where, that is in sum. So my program is completed. I written the program. So I just go for saving it before compiling. I just go for saving it. I give a name, that is sum of two numbers dot c. I given a name to it, sum of two numbers dot c. I gave a name, then I'm going to run this program. Look at this program. To execute and get the result, I'm supposed to compile. I compiled. So when I compile, I didn't get any errors. That means my program is 100% right. Sure, I have an header file, I have a main function, I have declared all the things right. Then I am going to run this program. When I run this program, you can see what the way I get the output. It is asking me to enter the value for a. I'll enter a value for a is 10. Immediately it is asking for me to enter a value for b. I'm going to enter 40. I entered. Immediately I got the answer is 50. 50 in decimal points. See 50.0000. Because I have taken float, it will give 6 decimal points. If at all I go for taking double, it will give 12 decimal points, 8 decimal points. It is system dependent. Okay, so it is giving 6 decimal points, so it is in float. So I can go for making some more change. The sum is, for example, now I go for making a change. The sum of, I'll write here, I can go for sum of a. Sum of a, where is a? I write percentage d and percentage d, no, percentage f is. So what is percentage d? I need to mention here percentage d is a, and what is percentage f? That is b, comma. Now I go for getting a different output. In the output window, I can go for saying compile it. You have just compiled, made some changes, compile it and run the program, execute the program. When you execute, now again it will ask you to enter 20 and I entered 100. Then you can go for saying the sum of 20 and 100 is 120. 20 and 100 is 120. Now I can go for making one more change. Look at the change. Actually, I entered here only 120, but it is taken 120. As you can see, I entered only 120, but it displays is in points because it is taken as a value of float 10, 20. You can see the output. It is 20.000, but I given only 20. I have gave it only 20. It takes on 20.0 representing in a float value, decimal value. That's what. When if at all I want to give it in decimals, it also accepts in decimals. See here, I am going to run the program. When I run the program, I have given 10 here. I am going to give 20.50, enter. Immediately I go for getting sum is 10. Sum of 10 and 20.50 is 30.50. 30.50. So this is how my input is taken, and I can go for telling you one more example execution also. I am saying it run, and initially I need to give input as 10.10. I am giving 10.10. Immediately you can go for giving, you can take here the value of B something. It's given me the sum of 10 and 0.20 is 10.20. It is second is taken for the second variable and assigned it, and it has given me some garbage value, so it's not going to accept when whatever the specific data type we have defined, we are supposed to give only that specific data type. So I do one thing, I remove one bracket here, because I told you one thing, bracket should be matching. Sorry, not the brackets removed. If at all I remove one bracket here, you can see one bracket is removed there, parenthesis. Immediately you compile, definitely it was going to give you an error. That matching of the brace is missing. That is a programming rule. It is a syntax, we call it as a syntactical error or syntax error. So that's how we go for making use of the input output statements, data types and variables to write the programs in C. So let's stop this session here. We'll see it in the next session on some other day, next Saturday, following with the more advancements of using the input output functions, format specifiers and operators in C. So thank you all. Have a nice day. We'll take the leave.